Press the bell icon on the YouTube app and never miss another update.
Evaluation of the limits which is of the form 1 to the power of infinity. 1 to the power of infinity means that is limit as extends to a f of x whole to the power of z of x equal to limit extends to a means f of a whole power g of a, that is equal to 1 to power infinity. 1 power infinity, that is as x tends to a, f of x tends to 1 comma g of x tends to infinity. It is the complete meaning. Okay, now let us consider limit extends to a f of x whole to the power of g of x, that is equal to limit extends to a, just for f of x add 1 and subtract 1 without loss of generality. Now we did know already one standard formula. Limit extends to 0, 1 plus x whole to the power of 1 by x is equal to e. So here that is equal to, now f of x minus 1, let it be one function, then it is in the form of, means instead of x, fx minus 1 is there. Instead of 1 by x, z of x is there. So therefore limit extends to a, observe, it is what? X. Next, it is what? It's reciprocal 1 by x. That's why it is 1 plus f of x minus 1, okay, whole to the power of 1 by f of x, 1 by f of x minus 1, okay. Next, actually we have to write g of x. G of x means we can write like that, g of x. So therefore, for no loss of generality, we can write it as like that. Multiplication with f of x minus 1 and division with f of x minus 1. So that is equal to, actually a to the power of m into n equal to a to the power of m whole to the power of n, or we can write a to the power of n whole to the power of m. So therefore limit x tends to a, 1 plus f of x minus 1 whole to the power of, it can be 1 divided by f of x minus 1 whole to the power of z of x into f of x minus 1. So that is equal to, or we can write it as a limit for this also. Directly I will apply the limit here without taking another step. Limit extends to a, z of x into f of x minus 1. So that is equal to, totally this bracket value is E. E means approximately equal to 2.7. E. whereas f of x will tends to 1 minute I will write e power limit x tends to a z of x into f of x minus 1, just like that. Into means for to tell this function. Okay, comma, where as x tends to a, as x tends to a, f of x minus 1 will tends to 0, like that. Understand? Okay, so therefore limit x tends to a, f of x whole power z of x, if it is in the form of 1 to the power of infinity after substituting x equal to a, then it is equal to directly limit e power x tends to a z of x into f of x minus 1. So therefore its answer is e power limit x tends to, I will write to black ink pen, e power that is equal to e power limit x tends to the given point a z of x into bracket begin f of x minus 1. This is the standard result for the form 1 power infinity as x tends to a if the given function is of the form f of x whole to the power of z of x. Simply what I am telling that when we are substituting directly x equal to a, if we are obtaining the form 1 to the power of infinity, then directly we can take its answer e power limit x tends to a z of x into f of x minus 1. That's all. Its application, question number 1, limit x tends to pi by 2 sin x whole to the power of tan x. Here put x equal to pi by 2 directly, sin pi by 2 1, tan pi by 2 infinity. So therefore we are getting the form 1 to the power of infinity. That's why we are using this formula or shortcut. So that is equal to e power, of course it is f of x and this one is z of x. Limit x tends to pi by 2, x tends to pi by 2, z of x means tan x into f of x. F of x means sin x minus 1. So that is equal to, next we have to think of this area, means this function or value. Here again we are getting tan pi by 2 infinity into x equal to pi by 2, sin pi by 2 1 minus 1 0. Next we are getting infinity into 0. Of course that is equal to, this infinity is equal to 1 by 0 into this 0. So therefore finally it is 0 by 0. Therefore we are permitted to apply L'Hospital rule there itself. So that is equal to e power limit x tends to pi by x tends to pi by 2, x tends to pi by 2. So here we must get the form 0 by 0, for which I cannot change this. That's why write it as sin x minus 1 divided by tan x can be written as 1 by cot x, means it is cot x. Now verify x equal to pi by 2. Pi by 2, sin pi by 2, 1 minus 1, 0. Next, cot pi by 2, 0. So it is 0 by 0. In each and every problem, we must try to express this form 0 by 0 from 1 to the power of infinity. Okay. Later, we are permitted to use the L'Hospital rule. So, limit extends to pi by 2 differentiation. d by dx of sin x cos x minus d by dx of constant 0 divided by d by dx of cot x minus cosecant square x, that is equal to that is equal to answer e power x equal to pi by 2 cos pi by 2 0 0 minus 0 0 0 by minus 1, so that is equal to e power 0, e power 0 value 1, hence its answer is equal to 1, hence the problem. Next second question. Next second question. Here, number 2. Limit, is it visible? Here, limit extends to 1. Limit extends to 1. 2 minus x whole to the power of tan pi x by 2. Pi x by 2. Understand? Here, put x equal to 1. 2 minus 1. Okay, 1. Next, put x equal to 1. Pi by 2 into 1. Pi by 2. Tan pi by 2 infinity. So, therefore, clearly, it is 1 to the power of infinity. Now, follow the same formula. E power, that is equal to answer e power limit extends to given point 1. Next, g of x. So, this is f of x and this will be z of x. Z of x tan of pi x by 2 into next f of x 2 minus x minus 1. So just simplify it. E power limit x tends to 1 tan of pi x by 2 into 2 minus 1 1. It is 1 minus x. So here rough work. Put x equal to 1. Put x equal to 1. Then tan pi by 2, that is equal to, it is infinity into put x equal to 1. 0. So therefore we have to write it as in the form of 0 by 0 on putting x equal to 1. That's why it can be written as limit extends to 1. Limit extends to 1. 0 by 0 means 1 by 1 minus x. We cannot change this. That's why I put the same 1 minus x whole divided by. It can be written as 1 by cot of, means it is cot of pi x by 2. Now clearly by putting x equal to 1, it is 0 by 0. Now we are permitted to use or apply L'Hospital rule. Here apply L'Hospital rule. Here also apply. Now apply L'Hospital rule. Okay. Next. So that is equal to, you come here. That is equal to e power limit x tends to 1. X tends to 1. D by dx of 1 0 minus d by dx of x 1 divided by d by dx of cot of f of x. D by dx of something cot of f of x is equal to minus cosecant square of f of x into f dash of x. So minus cosecant square of pi x by 2 into f dash means pi by 2. That is equal to e power. So minus cancel. It is 1 divided by cosecant square of, put x equal to 1. Put x equal to 1 means pi by 2. Cosecant square of pi by 2 into pi by 2 means it is 2 by pi, 2 by pi, 2 by pi, right here, pi. So that is equal to e power 1 into 2 divided by cosecant pi by 2, 1 whole square, 1 into pi, 2 by pi. So this is the final answer. Of course, it is the finite value. It is the finite value. It seems to be indeterminate form 1 to the power of infinity. But ultimately, with the help of L'Hospital rule or limit e power limit extends to a g of x into f of x minus 1 form, we are getting ultimately it's a finite value. You see here. So ultimately, it is a finite value with the help of L'Hospital rule. Hence the problem. Number 3. Limit extends to 0. Limit extends to 0. 1 power x plus 2 power x plus 3 power x plus and so on plus n power x whole divided by n whole to the power of 1 by x. So clearly put x equal to 0, 1 power 0, 1, 2 power 0, any finite value whole to the power of 0 is equal to 1, 1, 3 power 0, 1, n power 0, 1, 1 plus 1 plus 1 plus and so on, n ones are there. Therefore, it is n by n equal to 1, 1 to the power of, put x equal to 0, 1 by 0 infinity. So therefore, on substituting directly x equal to 0, it is again 1 to the power of infinity. So we are using this formula. So that is equal to directly e power limit extends to 0, z of x means 1 by x into bracket begin f of x means total this function 1 to the power of x plus 2 to the power of x plus 3 to the power of x plus and so on plus n to the power of x whole divided by n minus 1 like that. So that is equal to first simplification e power it is e power limit extends to 0 here 1 to the power of x plus 2 to the power of x plus 3 to the power of x plus and so on plus n to the power of x minus n divided by n LCM n. So into 1 by x means it is nx. So therefore put x equal to 0. Put x equal to 0 means n minus n 0 by 0. So therefore here we are getting 0 by 0. This one is 0 by 0. Therefore here apply the L'Hospital rule. L'Hospital rule. So that is equal to e power limit x tends to 0. Actually d by dx of standard formula, d by dx of a to the power of x is equal to a to the power of x into log a. So that is equal to a to the power of x means 1 to the power of x into log 1. Of course log 1 to any base 0. Next plus 2 power x into log 2 plus 3 power x into log 3 plus and so on plus n power x into log n minus, we are differentiating with respect to x but not with respect to n. Therefore with respect to x it is the constant. Hence d by dx of n means d by dx of any constant that is equal to 0. So divided by 0 whole divided by minus 0 whole divided by d by dx of n into x means n into d by dx of x equal to 1. N into 1 equal to n. Okay. बरोबर. So maintain the bracket. Now it is e power. Now put x equal to 0. Of course its value is equal to 0. Next it is x equal to 0. It is a pure constant. 2 power 0 1, 3 power 0 1, and so on, n power 0 1. So therefore it means log 2 plus log 3 plus log 4 plus and so on plus log n whole divided by n whole divided by n, like that. So that is equal to e power. Actually it is logarithm of 2 into 3 into 4 into and so on into n. So therefore whole divided by n means it is 1 by n. So that equal to e power 1 by n into logarithm of here 2 into 3 into 4 into and so on into n can be written as 1 into 2 into 3 into 4 into and so on into n. Next this 1 by n can be written as whole to the power of 1 by n. Already I said the properties of logarithms. So it is e power. This is that is equal to e power. So that is equal to another standard formula. E power log f of x, any function to the base e. This base is same, its base main base is same. In such a case it is only simply f of x. So therefore it is 1 into 2 into 3 into and so on into n whole to the power of 1 by n. So that is equal to, actually this is n factorial. It is n factorial whole to the power of 1 by n. Similarly, okay, I will show some examples. So therefore limit x tends to 0, 1 power x plus 2 power x plus 3 power x plus and so on plus n power x whole divided by, how many elements are there? n, and whole to the power of 1 by x. Simply it is, how many numbers are there? 1, 2, 3 and so on n. So it is simply n factorial whole to the power of 1 divided by how many numbers? n. So therefore of course it is the shortcut. Understand? Right. For example, another example. Of course it is the shortcut. Now I said the proof of the shortcut to know the subject. So example, limit x tends to 0, 1 to the power of x plus 2 power x plus 3 power x divided by 3, n value 3. I am taking n value 3. It is whole to the power of 1 by x. Simply n factorial. N factorial means n equal to 3. It is 3 factorial whole to the power of 1 by 3. That is equal to 6 cubed root of 6. This is the answer. Or 1 minute. Another example. Limit x tends to 0, a to the power of x plus b to the power of x plus c to the power of x whole divided by 3 whole to the power of 1 by x is equal to, actually it is what you see here. It is what? Product from 1 to n. How many elements are there? A, B, C. So therefore write its product. A into B into C whole to the power of 1 by n means n value 3, or simply cubed root of A into B into C. Similarly we can write limit x tends to infinity 1 to the power of 1 by x plus 2 to the power of 1 by x plus 3 to the power of 1 by x plus and so on plus n to the power of 1 by x whole divided by n whole to the power of x, that is equal to same answer, n factorial into whole to the power of 1 by. Therefore, we can write two shortcuts here. You come here. Number one, limit x tends to 0, a1 power x plus a2 power x plus a3 power x plus and so on, means any numbers a n whole power x whole divided by n whole to the power of 1 by x, that is equal to, here we wrote the product of the numbers, means a1 into a2 into a3 into and so on into a n whole to the power of 1 by n. This is the shortcut. Next, another shortcut. Limit, is it visible here? Limit x tends to infinity. Same just like that. a1 whole power 1 by x plus a2 whole power 1 by x plus and so on plus an whole power 1 by x whole divided by n whole to the power of only x, that is equal to same answer. Product of the numbers a1 into a2 into and so on an whole to the power of 1 by n or nth root of, we can write like that. So this is the shortcut and it is also the shortcut. I said the proof by taking 1, 2, 3, 4 and so on n, like that. It is important problem, important shortcut. Number 4. Limit x tends to 0, sin x divided by x whole to the power of sin x divided by x minus sin x. Actually, put x equal to 0, sin 0 by 0, as x tends to infinity, sin x divided by x1. So 1 to the power of 0 by 0 means indeterminate form. So therefore, it is also goes to this model, 1 to the power of indefinite, means not defined, just like that. 0 by 0 not defined, indeterminate form, right? So therefore, again we are using this formula. So that is equal to e power limit x tends to 0 z of x. This is the z of x. Sin x divided by x minus sin x, z of x into f of x. F of x means sin x divided by x minus 1. It is completed. Next, that is equal to e power limit x tends to 0. Actually, it is sin x divided by x minus sin x into, just simplify it, sin x minus x divided by x. So that is equal to e power limit x tends to 0, sin x divided by x minus sin x. Here we are taking a minus common into x minus sin x whole divided by x. So therefore, clearly x minus sin x will be cancelled. It remains e power limit minus, take outside, x tends to 0, numerator sin x, denominator x. So that is equal to e power minus, this value is 1. So answer is 1 by e. That's all. Hence the problem. Fifth question. Question number 5. Limit x tends to infinity 2x square plus 2x minus 1 whole divided by 2x square minus 3x minus 2 whole to the power of 2x plus 1 divided by 2x minus 1. So clearly, already I said when the degree of numerator and denominator is the same, as extends to infinity we are taking only quotients. Next here also x power 1, the degree of numerator is equal to degree of a denominator. Then as extends to infinity it is 2 by 2. Understand? Just like that. So therefore here we are using this form. So that is equal to e power limit x tends to infinity z of x. Z of x means what? 2x plus 1 divided by 2x minus 1 into f of x, total this function, 2x square plus 2x minus 1 divided by 2x square minus 3x minus 1 minus 1. So that equal to e power limit x tends to infinity 2x plus 1 divided by 2x minus 1 into here LCM 2x square plus 2x minus 1 minus of this one 2x square minus 3x minus 2 whole divided by 2x square minus 3x minus 2. So that equal to e power limit x tends to infinity 2x plus 1 divided by 2x minus 1 into here 2x square cancel, minus into minus plus 2x plus 3x 5x, next minus 1 plus 2 plus 1 divided by x square minus 3x minus 2. By using factorization it is 2x plus 1 into clearly x minus 2. This is the general procedure. So therefore here 2x plus 1 cancel, that is equal to e power limit x tends to infinity 5x plus 1 divided by 2x minus 1 into x minus 2. Here as x tends to infinity, its degree is 1. Next degree of denominator is equal to 2, because on multiplication 2x into x we are getting x square. So therefore degree of numerator is less than degree of denominator, because its degree is 1, its degree is 2, like that. So in such a case already I said the shortcuts, it is 0. So therefore e power 0 is equal to 1. Hence the final answer is equal to 1, just like that. Hence the problem.